So a colleague of mine suggested using my phone for the audio, and that might work better than using the laptop audio. So we're going to give that a try. That's why I'm on this meeting 3 times now. There's the laptop one where the video is, there's the room, which is the view from up high, and then there's my phone, which is just my face. So hopefully this will reduce the echo, and I think you will be louder when you, folks online will be louder when you talk. So it'll be easier for me to hear you and with less problems of echo and things like that. So definitely let me know if this is better or worse. It's an experiment. If it doesn't work out, you know, great, we'll just try something different. But if it does improve things, that would be good to know, and we can keep doing. Okay, so it is actually 9:16 now, so we should start. For those of you who are not in Minnesota, it got cold this weekend. We actually have a frost warning for tomorrow. No, tonight. No, yeah, I don't know, soon. It might freeze. So we've gone from summer to fall. Welcome to Minnesota. So no. And then send me a push. Going through the feedback after Friday's lab, one thing that was clear to me, well, that seemed clear to me, one never knows for sure, but seemed like a thing, was that there were almost certainly questions that weren't being asked. And obviously, the situation's difficult, right? For those of us in the room, we're all wearing masks. Most of us don't know each other. It is not a conducive environment to having a meaningful, heartfelt conversation and bearing one's soul about what one does or doesn't understand about, you know, Python and Jest. And obviously, for the people at home, the situation's not any better, right? It's different, but you know, there's definitely a lot of barriers between me and you and each other that make this hard. And so it seemed that there were a lot of questions that hadn't been asked, and that it would be useful to actually try to ask some of those questions. So one of the things that I did this morning is I posted this assignment. Is that coming through okay at home? Yep, coolio. Posted this assignment. Oh man, small screen. Where I'm basically asking you to share something you've got a question about. Okay, because I can't help if I don't know what people are confused about. And so what I'd like everybody to do is start off the beginning of class by actually just doing this assignment. So take like 5-10 minutes, however long you need, to think about what is something that you aren't clear on, or something you would like to understand better than you think you do now. And it could be a particular concept. So like, you know, a Python thing, like I don't really understand for loops. Or it could be a Jest thing, like I don't get the whole pixel image business. It could be an example from the book or an example that I did that you don't feel like you really understood as well as you wanted to. Or it could be whatever, right? I want this to be really pretty open-ended. If you can be specific, that makes my life easier. If you sort of throw up your hands and say, computers confuse me, well, that's a valid feeling, but it's hard for me to help other than a hug. And hugs are kind of out at the moment. Not that they were probably a real good idea for like an old middle-aged white dude to be like hugging random students anyway. So, you know, the hugging thing not going to win. But it's you know, it's not clear how to help under those circumstances. Whereas if you can be like, this example confuses me, or I don't get how to use this function, or why this is this way, then that gives me something like more concrete to grab onto. But if what you've got is a generally vague sense of unease, like tell me that that's what you've got, right? I'll work with what we get. But if you could take a few minutes and do this, that would be awesome. Is there anybody here who doesn't? Okay, everybody has a laptop, so I think we're all good. I've got index cards in case somebody was not computered up, but I think everybody's got gear. So, and obviously anybody who's watching online has a computer, or you wouldn't be here. So I'll be quiet. Okay, so we'll wrap up here in just a sec. I got a couple more to look at. So if you're working on something, try to finish it up soon. Okay, I think everybody that is present, by some definition of present, has submitted something. No, I mean, no, there's at least one person that hasn't submitted something, but I think all but one have. So let's go ahead and get started because that gives me a pretty long list of things to think about. Okay, so the short answer is the winner is for loop. Probably. There were a number of questions about for loops, requests for more for loop examples. Somebody felt like they kind of understood them, but weren't sure how to use them. Didn't really know how to apply them to solve problems. There was a question about variables in for loops. Does it always have to be I? What are the rules about that? There was one question which I think could be interpreted as my for loops don't work and I don't know how to fix them, sort of a debugging problem around for loops. So there was quite a few things there. There were different questions about picture editing, sometimes specific examples, like the sepia tint example, some more general, like this is weirder and harder and stranger than I expected it to be. There were a couple of questions about indentation, so I think we clearly need to talk about that some. There were a few specific questions about problems, so the space it out exercise in 3.5, a couple of the examples from chapter 3 about strings, posterization, an example from chapter 5. There was a question about else, while, and return. I think there was another, there were at least 2 questions about returns, so I think we can talk about that. And then there was 1 or 2 questions about the collage assignment, which we haven't even talked about, and I think it's still listed as due like day after tomorrow. That's nonsense. Just don't freak out about that, because I think for that to be due day after tomorrow would just be chaos and it would be badness. So part of my deal was to try to figure out where people were today and then make some decisions about the timing of some upcoming things, including collages. But it's clear to me that having collages due Friday would be just complete goofiness. Now, what that does to the overall schedule is less clear to me. I mean, if you move something, like all the other stuff's got to shift down too. And so there's consequences, and I'm not sure what those consequences are going to be, but at least the short-term tactical decision has to be that collage can't be due Friday, because I just don't see how we would get good work and people would feel like they would understand the material. And the main thing here, I want you to understand what's going on. So we will move that. Exactly how it will be moved and to where and what some of the longer strategic implications of that are, not clear to me yet, but we will, move that around because I don't want to kill everybody. Killing people, not good. Okay. So I'm going to plug in the tablet and I'm going to violate the rules and move a piece of furniture, but I will put it back, and I'm not moving it in a way that puts me closer to people. I'm moving it in a way that puts me farther away from people. So I'm being good. And I have witnesses. Hopefully you agree. But I do want to be able to draw some stuff. I think that will be helpful. And drawing works better on the bigger page. Open this around. People can see me. And that's an invisible blob. Okay. So let me talk in space a little bit and draw on a whiteboard some. And then we'll actually pull up Jess and do some more concrete code stuff, okay? So I'm going to share whiteboard, sharing. Come on, hit the button, there we go. Great, looking at the whiteboard, that is awesome. I'm going to change that to this. And those of you at home, if you've got questions, definitely just ask, and hopefully my phone will make a nice loud noise, and we will know that you're asking a question. In fact, it might be loud enough that people in the room can hear. I don't know. Okay, so let's talk a little bit about for loops and indentation, and maybe return while we're at it. Okay, because I think we can strike 3 of these questions in one fell swoop to some degree. Okay, so let's imagine I've got 4 X in items, colon. Now, this is called a lot of things. I'll call it the loop variable for today. It is the name for the current item we're processing. Because it's a name, we can choose it to be whatever we like. Okay. Now, what does that mean? So let's say I need to take some action for every student in the class. Maybe I need to grade exercise lab 3. Maybe I need to give each student in the class a crown. Maybe I need to send everybody an email letting them know that, letting you know that I'm not going to be sitting outside in the frozen cold after class today. In fact, just as a aside, the sitting out on the lawn and meeting people has been pretty much a complete bust. One person came for about 20 minutes the first day. No one else has ever come since. And when the weather was nice, I was like, yeah, fine. The weather is not what I would call nice now. And the idea of sitting outside in the cold, not talking to anybody, has stopped appealing. I think I'm going to officially cancel that. And what I'll probably end up doing is creating some more appointment slots on Monday and Wednesday that would be sort of take up that time. So I'll still be available, but I'll just be available by a different means. So maybe I need to send you all an email that says that, okay? Now, so coming to the question of like, when do you use a for loop? One way to think about that is whenever there is a set of items and you want to do the same thing to every item, okay, that's a for loop, the same action. Now notice the actions can depend on the item, okay? Grading one person's assignment isn't necessarily going to give them the same grade as grading another person's assignment, right? The outcome of the actions can be different, but the action, I need to grade this assignment and I need to grade that assignment, the actions are the same, even if the outcomes are different, right? I might have a lot of numbers and I want to square them all. Well, the action's the same. I'm squaring all of the numbers. The outcomes are different because the square of 2 is not the same as the square of 10. Does that distinction make sense? Okay. So whenever there's a collection of things and you want to do the same thing, take an action on all of them, for loop, totally your friend. It is going to be the thing you probably want to use. Now, one of the challenges there is I need a name for each of the items in the list as I go through them, because I have to have some way of referring to the item. So if I want to say square all the numbers, I'm going to have some function, some action that squares things, but it needs to know square what, right? I've got to have a name for the thing that is being squared. And I can't have the actual constant there because that's going to change. One time through the loop, I'm squaring 2. Another time through the loop, I'm squaring 7. Another time through the loop, I'm squaring negative 8,527,315, right? So I can't have those numbers there. So I need a name for the current value that I'm processing. That's what this loop variable is. This loop variable is the name, and it is a name I just make up. I can use whatever name makes me happy. I can say for small frogs in pond, right? If I do that, and as long as I square small frogs, then life is good, okay? It's a name that I choose and that I can refer to in the body of the loop, and that will be whatever the current value in the list that I'm working on is. And I can use whatever name I want. So we can use I, we can use P, we could use frogs. It doesn't really matter as long as we're consistent about it, okay? That's the important thing. And so the choice of the name is mostly a human readability question, okay? If by choosing the name, we can convey some information to a human reader, that might be good. So using frogs, when the things in the list are definitely not frogs, probably not helpful. If the things in the list are numbers, I could say for num in item. And that would help convey that the things are numbers. If the things in the list are pixels, because they came from an image, using a name like pixels or pix or p, if you're really averse to typing words, would convey varying degrees of information, okay? Does that make sense? Questions about that? Questions at home? Okay. So let's actually look at an example in Jest quick, and then we'll come back to the whiteboard as well. Should have started up Jest soon. Okay, so now I need to stop sharing that and start sharing Jest. Unfortunately, it is not trivial to flip back and forth. Okay, so let's say that I have a function square all that takes a list of numbers So there's a little for loop. So I'm saying for num in numbers, square num. Now we haven't at the moment done anything with the square. If I run this function, actually, it's really going to do nothing. This is the rough equivalent of me handing you a list of numbers and saying, square all these. And you're like, sure, fine. And you go through, and like the first one's 2, so you square 2 and you get 4. And then the next one's 10, you square 10, you get 100. But I haven't told you what to do with the result. So you do all the squaring, and you just don't do anything with the results because I didn't tell you what to do with it. And you get to the end and you're like, done, squared all the numbers. And I'm like, great, what were the answers? And you're like, you didn't ask for the answer. You just asked me to do the work. That's actually what's happening here. This is squaring all the numbers and literally throwing away the values as it goes because we haven't told it to do anything with the value. So it's doing the work, but we don't ever get to see the answer. And that's kind of awkward and probably not useful. So one thing you should always think about is like, what are you doing with the result of the work, okay? And sometimes you're modifying something in place. So with the pictures, you're actually modifying the picture that you were given. And you don't need to return anything. You just modify the thing as it is. It would be like if I handed you a list of numbers and I said, write the answers on the piece of paper I gave you. So you would be modifying the thing I gave you, and then when you were done, I would have access to it, and I could look at it and see the answers. In other circumstances, you have to return a value back to me. You have to send me an answer, okay? So if you were to call up a friend and say, hey, I need so-and-so's phone number, and I'm pretty sure you got it. Person could be like, oh yeah, I have that. Let me look it up. And they look it up and then they just hang up the phone, but they don't tell it to you, right? They've done the work, but they didn't give you an answer back. And you kind of needed an answer back. And the way you provide an answer is return. Return is the tool that says, I have an answer here, I'm giving it back to you, okay? So we could, in this example, say have result is initially the empty list, and then result dot append num square num and return result. This says, I'm going to give you a list of numbers and I want back a list of the squares. That means you have to build the list of the squares. So you have to start off with an empty list, and that's what result equals open close square bracket does. Open close square brackets is an empty list. And we're giving that a name. We're calling it result. Again, result is a name. It's just a name I made up. I could have said frogs equals empty list. And then as long as I use frogs down here for result and frogs right here where result is, that would work fine. It's just not a very good name from a human perspective, right? I could also have said squares. Squares might have been a good name because that's the thing I'm sending back is the list of squares, okay? Does that make sense? Questions about that? Going. We good at home? Okay, thank you. Okay, so then append is a built-in function in Python that takes a list and it uses this dot notation. We haven't really talked about this dot notation, but the basic idea is you have a noun, which could be a list, or it could be a picture, or it could be a sound, it could be a lot of different things, and then a dot, and then a verb. And you're saying, do this verb on that noun, okay? So we're saying, do append on this list. And append only works on list. And it allows us to add something to the end of a list. Okay. And what do we want to add to the end of this list? We want to add num times num, the square of the current value in the list that we were given. And then when we're all done, we want to return result. So the whole for loop will happen. This will process all of the values. When that is complete, then we will come down here and do return result. And we'll say, we did all the work. We wrote all the answers in this new list. Here's the new list back. And we'll hand that back to the person who called this function so they will have the answers that they wanted. Okay. Questions before we try actually running this? Let's save. Let's see, where did I put this? Desktop, right? Desktop. There it is. Yeah. We have CSci 1201 2020 09.py. Load. Let's see if it works. Square all 5, 8, 9, 6, 3, 2, 0. And indeed, we get a list back that has the square of each of those numbers. So we squared 5, put it in the list. Squared 8, put it in the list. Squared 9, put it in the list, et cetera, et cetera, et cetera. Built up that new list and handed that back. Okay. Now, there almost certainly are questions here. This is one of these moments. I mean, one of the things that's always hard about a class like this is that when I do it, it looks easy. Everything tends to work the first time. I don't misspell things or put colons in the wrong place as often as you do because I have done it for a while. And so it feels like, oh, that's really straightforward. I get it. And then you go home and try to do it. And then it's like, and it doesn't work. And that's part of why I want to have the lab days on Friday so that you're actually typing and you can call me in and be like, it doesn't work and I don't understand why. Because that's the more realistic experience. Okay. And totally don't feel bad if you have this like, oh, it's easy when Nick does it, but when I do it, nothing seems to work experience. That is really common in computer science in my experience. It's also pretty common in a lot of math classes that the proof looks easy when the prof does it, and then you go home and try to prove something similar, and it's like, oh, and it's really frustrating. And I've had this experience. I had a class in grad school from a pretty famous guy who did these gorgeous proofs and programs in class. I mean, they're just beautiful to watch. And it was like watching somebody, paint masterpieces. And I would go home and I felt like I was just, waving a stick around with paint on the end. It was just frustrating as hell. So you're not alone. These things happen. But definitely ask questions as we go along. It's a good thing. So are there any questions about this example? So we got a for loop. We're going through a set of numbers. We're squaring each number. We're putting them into a list with the append thing. And then we're returning at the end. We're saying we're done, return at the end, okay? Now I want to say a little bit about return and indentation here. But if there are other questions before I get to that, that would be awesome. Okay. Yes?
If you were to put a return result at the start of this function, it wouldn't work, right?
Well, so let's. Do you mean like at the very, very start?
Yeah. Or
okay.
The return result you were to put at the very beginning.
Well, let's see what happens. Okay. So Nick's idea, And actually, quick question. At home, could you hear next question on my phone, or do I need to repeat next question? You can hear it okay? Cool. That's awesome. That's definitely better than the computer audio. So, so Nick was like, what if we put return result at the very top? Let's save that. I mean, and this is one of the great things about computers is if you've got a question, one thing you can always do is just try stuff. Because the worst thing that happens is it doesn't work. But you can't really break the world, right? You can't really break your computer. The worst you can do is just have to like maybe quit Python and start it again. But as long as you save your work, you can't actually do any real damage to the universe. So if you've got a question, try it out, right? That's the best way to learn this stuff in a lot of cases. So does anybody want to take a guess as to what would happen? I mean, you suggested it wouldn't work. Do you have an idea of specifically what that means and what we're going to have happen? Do you have a set? Can you say something about why you think it won't work?
I think that it's going to try and do that in the order that it's given. So
Yeah.
It's not going to actually have anything listed. It's just going to return nothing.
Good idea. So there won't be a value for result yet. So it's going to return something that means I don't know what the hell result is. So that could be an error, or maybe there's some sort of notion of an undefined value. In fact, it's an error. Okay. So we got, let me scoot this up a little bit. So the local variable result reference before assignment. So it highlighted the line and it's saying we're using result before we ever gave it a value. That's what it means by reference before assignment. So we're using it, it's referenced before we assigned a value to it. And so it's like grumpy, 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 grumpy. That doesn't work. So you're completely right about that. Questions about that? So it does do things from top down, essentially. You don't want to have the return at the beginning because you haven't done the work yet. Okay. So let's put that back down at the bottom. Ah, wow, what happened? There we go. That's better. Okay. And that, let's make sure we didn't re-break things by my flailing around. Okay, now it works. Now, let's think a little bit about indentation. And in particular, let's consider this last line is currently sitting here lined up with the for loop. What if we indent it? Now notice that the square around the return result moved. If I back up, the square goes from the result equals empty list all the way to the bottom. And that's saying that whole thing is a block that's going to be treated as a unit. And its blocks are always attached to the line right above them, which needs to end in a colon. So in this case, this block is attached to the def line, and it is the body of the function we are defining. Okay. If I move it in, now its box has changed. It is now part of a smaller block that is just the return and the result.append line. Those are now a pair of things that go together, and they are attached to the line right above them, which is the for loop. So they have become the body of the for loop. And before, the result was the only body, the result.append was the whole body of the for loop, was just that one line. So that one line was the thing that was done every time. Now, if I indent this, what's going to be done every time is the result.append and the return. And people often think that's a good idea. However, it is not usually a good idea. It depends on what you're trying to do. But returns are really aggressive action. When you have a return, it returns the value that you have at that moment and ends the function. The function stops right then, even if you're in the middle of a while loop, okay? So if my program says I'm supposed to go around the room and give everybody a $10 bill, but I have a return in the wrong place like this, I would come in, I would give Molly a $10 bill because Molly's the first person I see. I would then see the return statement and I would turn around and leave the room and I'd be done. And the rest of you just got screwed. Nobody else got $10. I'm sad. And I don't know how we would have done the $10 online, but yeah, we deal with that. So a return too early can be a real problem because it ends the process even if you were in the middle of doing something like a for loop. And so if we put this here and save and load and run the program, we get the first square and nothing else. So it goes to the first item, which is 5, it squares it, it puts that in result on this line here. Then it comes to this line here and says, I'm going to return result right now and end. And result has just 25 in it. That's all it's got. And so the program's like, sure, if that's really what you want to do, computers are very good at doing what you tell them and not what you mean. And this is probably a case of doing what you told it and not what you meant. And so it's going to return that result and end right there. And so we only get 25 when that was probably not what we meant. Okay. So that indentation matters a lot. Where the return is relative to the other line in the body of the for loop matters a lot. And Python, and this is a Python thing, not a Jest thing, Python uses indentation to indicate the grouping of lines into blocks, which is rather unusual. There are some other programming languages that do that, but not many. Most of them use more visible syntax, like open curly brace, close curly brace, or the word begin and the word end to indicate blocks. But Python does it all with spacing. So the spacing really matters. One of the nice things is that Jest gives you these boxes to show you what the grouping is at any given point in the program. So if you're ever uncertain about, well, like, how is this going to get connected to the other parts of the program, you can use these boxes to sort of see that. They will visualize that for you, okay? Now that's sort of a weird idea. Are there questions about the return, questions about the indentation, about blocks? Was this helpful so far? Has this been a useful thing to do? A few people were kind and nodded. Okay. Okay, then let me actually try, what if we move the return all the way out here? Now notice that return isn't in a box anymore. We've left the function. It's not part of the function anymore. When it was over here, it was part of the body of the function. But when I move it out, it stops being part of the body of the function. That line is no longer anything to do with the function. So the function does not have a return statement anymore. So it will never return a value. And this return result is now floating in space and is going to have a problem because I think there are going to be at least 2 problems. I'm not sure what the error is going to be when we run it. But there's a return that's not inside a function, and returns need to be in functions. You got to return from somewhere. Returning just in space, it's like return to where? I don't know where you came from. And result doesn't mean anything out here. Result meant something in the function, in this box under the function, but it doesn't mean something out here. And so even if return made sense, we would still get the same error that we had before about referencing something that hadn't been defined yet. So I'm not, like I said, I'm not 100% sure what error we're going to get here, but let's go find out. Invalid syntax. Your code contains at least one syntax error, meaning it is not legal Jython. The error is on line 5. Well, that's really not helpful. And I apologize. I think what this actually means is that there was a return that wasn't in a function, and it got really confused about what the hell that meant. And instead of saying something useful, it went and fell over and died. So not a very great answer on the part of the program. But that's because the return's sort of out in space, and returns can't be out in space. Okay. Oops. Undo. What did I do? There we go. Okay. Make sure things still work. We're all. And we could also use the range. Right? I get squares the first 10 natural numbers. Woo-hoo. Very exciting. Question? No. Anybody else got a question? Okay, so we've talked about for loops, sum. Now, so let's say we've talked about indentation and return. Let me do one other thing with return. And this will also bring in if and some other indentation voodoo. Let's imagine we want to write another function that's going to be like this: square up to negative number. And actually, let me put a comment on this. So this should takes a array of numbers and returns an array of the squares of those numbers. Okay. And then here, we're going to take an array of numbers and return an array of the squares of the numbers up to the first negative number or the end of the list, whichever comes first. So in this one, when we see a negative number, we're supposed to stop and ignore the rest of the list. Okay. So if I'm coming in and I'm giving everybody a $10 bill, maybe when I first reach a millionaire, I'm like, oh, well, this is silly. I don't need to give millionaires $10, and then I quit, which is probably not great. I probably ought to just skip the millionaires and keep giving $10 to everybody else. But you know, let's just say I'm weird and I meet a millionaire and I'm just done. So it's going to look very similar. So we'll have result is the empty list, and then for num in numbers. Now for every number in the list, I want to square it and add it to result, but I also need to check to see if it's negative. And if it's negative, I want to quit early. Okay, so I'm going to do if num less than 0. And if num is less than 0, I'm going to stop right there and return whatever I had. So I'm going to return results. And as we saw earlier, when I get return, it ends. Like that's it. We will not look at any of the other numbers. So this says return what we have and quit. We are finished. Okay. And then we can also say else. So, and it's often the case when we have an if that there's a thing we want to do if the test is true and a thing that we want to do if the test is false. Okay. So we might be, if it's sunny, wear a hat, otherwise wear an umbrella. or take an umbrella. I guess you don't wear an umbrella. Okay. And so, it's often the case that you want to do one thing if the test is true and another thing if the test is false. And else lets us say, here's what we're going to do if the test is false. Okay. And so if the test is false, then we want to go ahead and square num and append that to the list. And if we get to the end of the for loop, we finish the whole for loop. And notice that the body here of the for loop is the whole if-else thing because of the indentation. So if we get to the end of the for loop, that means we will have processed all of the numbers and we will have never returned. So we still have to return at the end because we won't have done it early, okay? So this is sort of like, while we're flying, if the plane is on fire, jump out of it. Otherwise, keep flying. And at the end, we land. We still have to get out of the plane, right? We don't want to just sit there. So there has to be a leave the plane instruction at the end of the process. If we've jumped out of it already, like we're out of the plane, hopefully with a parachute, that would be much more useful than simply jumping out of planes without parachutes. But if we land successfully, right, we still have to leave the plane. We still have to return the set of squares. Nick.
Theoretically, if you swap else with numbers greater than 0, that also works?
Greater than or equal to 0. Yes. In fact, I mean, there's several options here because return is preemptive. We could skip the else altogether. But for now, I'm going to leave it like this. And given the time, we'll probably not play around with it too much more, but we could. There's a whole bunch of things we could try here. Questions before I load and run? Oh yeah, I need to save. And it doesn't like, can somebody tell me what's wrong with this line? Somebody other than Nick. I'll be mean to Nick. No colon, good catch. So now save, load, hey, it loaded. Square up to negative number. Now, if I don't give it any negative numbers, it does the same thing. If I make, let's say 6 into negative 6, I only get the first 3 squares. I get the square of 5, 8, and 9 because they're all positive. Then it hits the negative number, a value less than 0, and it returns right away. Okay. So this return here ends the execution at this point. So this is a place where sometimes we do want a return inside something if we need to leave early under certain circumstances. And there are, legitimate times when you want to do that. If I'm trying to find the first student who isn't registered for classes next semester. At the moment, nobody's registered for classes next semester, so don't freak out. I haven't sprung something on you. But let's imagine it's November and most people have registered. I might want to go through the room and find the first person who hasn't registered, take them, make sure that they get registered for spring semester, right? And so I might want to end early when I find the first person that has that property, okay? So there can be times when you do want to return early. And, this is a little forced, but it's a reasonable answer to the question. Okay. Questions about any of this? We've got 3 minutes. Somebody ask an awesome question or even a boring question. Joseph. The else if, yeah. So sometimes you have chains of things, like here we just had negative or not negative. imagine that we want to have negative, 0, and positive as 3 separate cases we want to deal with. And let's imagine that the 0 case, we just want to keep going. Oh no, let's say we want to append 100 for some reason. Okay. If num equals 0, result append 100. Well, that's to make it minus 100, since squares are never negative. Then what we're saying here is if the number is negative, end right away. If the number is 0, append minus 100 to the list. Otherwise, append the square to the list. And elif is else plus another if squidged together into a word, because somebody thought that was clever. I'm not sure that I can really justify that decision, but that's how they do it in Python. So you can have if, elif, else. You can have as many elifs as you want in the middle if you need them, okay? And so this, if we, let's say we put some other numbers in there, we get 5 squared is 25, 8 squared is 64, 7 is 49, 0, we get this weird negative 100 thing, but we keep going because we don't have a return there. And then 4 squared is 16, and 9 squared is 81, okay? Does that help answer the question? Okay, so class is basically over. 2 questions quick before everybody leaves. First, was this a useful way to have spent a day? Okay, good. I'm getting various nods from the room. People at home, was this an okay thing to do? Yep, I'm getting some thumbs up. Okay, so I think we may want to do more of this. I'm going to move some assignments around. Like I said, I'm also going to skip the whole sitting in the freezing grass business and create some more appointment slots. I would strongly encourage people who are working on assignment, who have questions, to grab an appointment slot. And if none of those slots work, let me know. Don't just quietly suffer, right? I mean, the point is that you're paying me to help you. So if I'm not doing that, then you're paying for not very much, and that's not very useful. So try to make sure that I can give you a hand. Okay, I will let people go. We will talk to you later. Ciao. And I'll post the code and the video as soon as the video gets done being processed. So you'll be able to watch all this again later. And folks at home, was the audio still pretty good today? Was this a good thing to do on the audio front?
Yeah.
Cool. So I think we'll keep doing the phone thing for the audio. And yay for my colleague Hussam for suggesting this, because I think that was a win. Okay. See you folks at home later. Ciao.